these are each V, and this is W degrees. So we know that this is 16 across the bottom. So I always hit the altitude to the right triangles. So this is going to be, and I know that this is 10, so I know that this is 10. So, hey, I can see it's a 6, 8, 10, can you? That's 6. Not that it matters, but now you have to find the measure of V, degrees. So I know all of these side lengths. I can pick any ratio I want. I can use tangent, opposite V over adjacent. I can use inverse sine, opposite over hypotenuse. I can use inverse cosine, adjacent over hypotenuse. I'm trying to find the measure of the angle. I know the side length. Molly, pick a ratio, any ratio.
Well, for mine, I did cos -1 or the inverse is 8/10.
Okay, so you said V, because it's the cosine of the cosine of V is 8/10. You said V is equal to the inverse cosine of 8/10. Okay, and so that should be it should be to the nearest whole degree, 37 degrees.
Yeah.
Okay, and then for W, well, you want to find maybe half of W and then double it, I guess.
Yeah, that's what I did.
Okay. So what did you use? What did you do? How did you find W? W is
Sine negative or
just say inverse sine.
So inverse sine is 8/10.
So you did 8/10 because it's opposite over hypotenuse. Okay. So, and you should get approximately 51.
Well, the answer is 106, so it'd be a little more than that.
Okay. So, I'm sorry, yeah, so 106 degrees. Is there another way you could have found that, once you knew that these were V? If you go back to the big original triangle, if you knew that V was about 37, can we automatically find what that angle is?
Yeah.
Yeah, so we could prove it by saying it's going to be 180 minus, 74. So that's also a way that we could get it to 106 degrees. So there's